Hello, in this video, I will explain how we can integrate sine inverse x dx. Sine inverse, it's the inverse function of sine, or as some references call it, arcsin. So we need to solve the integral of sine inverse x dx. Now I can write this also as integral of 1 multiplied by sine inverse x, in order to get a polynomial multiplied by sine inverse. Now 1 is a polynomial of degree 0. Now here we will have a product of two functions of different type. And in order to integrate a product of two functions of different type, we use integration by parts. Now the rule of the integration by parts that I'm going to use is the integral from a to b of u prime v dx is equal to uv between a and b minus integral from a to b u v prime dx. Now, one of the functions is going to be u prime. So we are going to choose one of these two to be u prime, and the other is going to be v. As I explained in other videos, always the inverse trigonometric function is going to be v. Because if we choose it to be u prime, we have to find u, which is its antiderivative. And this is the goal of this integral, is finding the antiderivative of sine inverse. So we're going to choose sine inverse to be v, and u prime would be 1. Always when we have an integral of a polynomial multiplied by an inverse trigonometric function, whether it is sine inverse, tangent inverse, cosine inverse, whatever inverse trigonometric function we have, this trigonometric function will be v in the formula of integration by parts. So as I said, u prime is going to be 1, which means u would be x, and v would be sine inverse x. V prime, it's 1 over radical 1 minus x squared, which is the derivative of sine inverse. Then we apply the rule of integration by parts. So we get I is equal to u by v. So it's x sine inverse x minus integral u v prime. So minus integral x over square root of 1 minus x squared dx. So we need to solve this integral here, which I'm going to call j. You can call it whatever you want, but I'm going to call it j. So j, it's the integral of x over radical 1 minus x squared, which I'm able to write also as integral of x, factor of 1 minus x squared to the power minus half, because the square root, it's the same as giving the power half, and when I take it from the denominator to the numerator, it's gonna be minus half. I'm writing the integral this way in order to be able to use the rule that the integral of u prime u to the power n dx, it's un plus 1 over n plus 1 plus c. I have another video explaining how we can use this rule, and I solve many integrals using this rule. Now, getting back to our integral, if u is 1 minus x squared, then u prime is minus 2x. So we need 2 here next to x. So if we multiply minus 2 inside the integral, we should multiply by minus half outside the integral. It's as if I'm multiplying by 1, which wouldn't change anything in the integral. So now I have minus half integral of minus 2x factor of 1 minus x squared to the power minus half, which is the form u prime u to the power n, and n is minus half, which means when we integrate, we would get minus half. This is the one that's outside the integral. You will get u to the power n plus 1. So it's 1 minus x squared to the power minus half plus 1. So it's n plus 1 minus half plus 1 over n plus 1. So minus half plus 1. And minus half plus 1 is equal to half. So we have it here. Minus half plus 1 is equal to half, which means we can simplify by half, which is the outside the integral, and half here. And having power half, it means it's square root 1 minus x squared. If we remove all these, we get that this is equal to minus square root of 1 minus x squared. And finally, remember that we are solving this integral, which was x sine inverse x minus j, which means finally I is going to be x sine inverse x minus radical 1 minus x squared, which is j that we found here, plus a constant c, and minus would become a plus radical 1 minus x squared plus c. And this is our final answer.